Welcome to part 3 of 4, looking at our provinces algebra and number 4 outcome for grade 10 math. We're focused on multiplying polynomials. We're going to look at our curricular outcome, review the distributive property and collecting like terms, and then we're going to look at multiplying polynomials with the box method. This is a method that makes missing terms a little harder to do. Then we'll get into examples and exercises. So our outcome: demonstrate an understanding of the multiplication of polynomial expressions, limited to monomials, which are polynomials with one term, binomials, polynomials with two terms, and trinomials, polynomials with three terms. We want to do it concretely, pictorially, and symbolically. So let's review our distributive property and collecting like terms. Our distributive property: when multiplying two polynomials, we multiply every term in the first set of brackets by every term in the second set. So if you're doing 3 terms times 7 terms, you'll have 21 terms before you start collecting like terms. Like terms can be collected by adding their coefficients, provided that they actually are like terms, which means they have identical variables with identical exponents. So how do we multiply them with the box method? Well, we sort each polynomial in descending order of degree. If an exponent is not represented, so if you jump from x to the 5th down to x squared, then you don't have x cubed or x to the 4th. Add a term with a 0 for that coefficient. And then you make a table, one polynomial across the top and the other on the side. Multiply each term on the top by each term on the left, put the products in a table. Collect like terms along the diagonals. Right. This is that putting them on the diagonals is why we use number 2, 0 with the coefficient. So let's do some concrete examples with this method. Let's multiply and collect like terms when we have this binomial times another binomial. So that means we're going to need 2 terms across the top, 2 on the left. The top left box here is just a placeholder. Let's put x plus 3 on the top. Put an x and a 3 at each of the top of the last 2 columns. On the left, 2x and negative 1. So each term gets its own box. Now, 2x times x is 2x squared. X times negative 1, negative x. 2x times 3, 6x. 3 times negative 1, negative 3. There's our 4 terms. We've caught them all. If you miss a term, that box will be empty. Our like terms will also appear on the diagonals, especially if we've used the placeholder zeros as needed. So, combining our x squared terms, we have 1. That's 2x squared. Our linear terms, negative x and 6x. Notice they're on the diagonal. That's coming from the bottom left to the upper right. That's our diagonal here. That's a negative 5x when we add them. We don't see a 1 in front of the x, that negative x, so the 1 is implied. Our constant is negative 3. That's our first pair of binomials multiplied. Doing it again. Notice this time we have an x squared term, we don't have an x in our first bracket. That means we'll need an extra column here because we'll have a placeholder of 0. So x squared goes at the beginning. That missing term is the same as 0 times x, so we put a 0x here. Now our constant is negative 5. We put the other 2 numbers in, 2x, then 3. Now, obviously, with a 0x there, everything in that middle column is going to be 0. That placeholder is there so we can still collect like terms along the diagonal. X squared times 2x is 2x cubed. X squared times 3, 3x squared. 0x times 2x is 0x squared. 0x times 3, 0x. 2x times negative 5. It's a negative 10x. And a negative 5 times 3 is a negative 15. Now, that middle column, could you have just written both as zeros instead of 0x squared? Well, yes, sure. But that, again, that column exists to help collect like terms. So our x cubed term, we only have one. X squared is the 3x squared plus 0x squared. X 0 plus a negative 10 is negative 10. And negative 15 is negative 15. Third and final example, 3 terms by 3 terms. We're going to have 9 terms before we start collecting like terms. So let's start putting them into boxes. X squared, 3x, negative 1. 2x squared, negative 5x, plus 4. We have our boxes set up. Every exponent is represented, so we don't need 0 x's anywhere. All right, 2x squared times x squared is 2x to the 4th. X squared times negative 5x is negative 5x cubed. X squared times 4 is 4x squared. 2x squared times 3x, 6x squared. Negative 5x times 3, that's 15x squared. And a 4 times 3x is a 12x. Last column, multiplying our negative 1 by everything in the first column, we'll just take that first column and change the signs. Here are our 9 terms. Now let's collect our like terms along the diagonals. We only have 1, 2x to the 4th. We have 2 terms with x cubed. 6 minus 5 is 1. We have 3 terms with x squared. 4, negative 15, and negative 2. So the same as 4 times negative 7, or 4 minus 17. Well, that is negative 13. Now 12 and 5, we add those together to make 17x. And the negative 4 is on its own. All right, exercises. Multiply and collect like terms. Pause now and take all the time you need. All right, moving on here, we have a 6x squared plus 13x minus 5. Exercise 2, r squared minus 3r plus 4 times 2r minus 1. Take all the time you need. All right, 3 terms by 2 terms gives us 6 terms to simplify. 2r cubed minus 7r squared plus 11r minus 4. Last one, 3 terms by 2 terms. That last one, I don't see an x. We're missing an exponent. How do we deal with that? Check back in a minute. For now, pause. Take all the time you need. There we go. That x term is a 0x placeholder, a whole row of zeros. And we end up with 2x to the 4th times 10x cubed minus 7x squared plus 5x minus 4. In summary, keeping information organized helps a lot when it comes to accurately multiplying polynomials. To reliably multiply polynomials, sort the terms by degree. Build a table with one polynomial across the top and the other down the side with 0 coefficients for missing exponents. Multiply terms at the top and side to fill in the bubble. Or fill in the table, sorry. Collect like terms along the diagonals. If you have any questions or feedback, please leave them in the comments. I can't promise how quickly I will get back to them, but I will promise that I will do everything I can to get back to them in a timely fashion.